Today what we're going to do is we're going to talk about solving linear equations. The key concept for this thing is that we're actually looking at a variable that makes the left and the right side of the equation true. Now to do this, we have to use opposite operations to isolate the variable. Now we always start with addition and subtraction first, and then when we can't do any more simplification, we have to do division if there's any possibility. Now, sometimes we call that change the side and change the signs. Now, the key concept for today is called isolation. Now, if you take a look at question number 1, you'll notice how I've put an arrow for 17 plus x, and I draw the arrow to the right side of the minus 3. What is that doing? Basically what we're doing is we're taking the 17, which is actually positive 17, and turning it into minus 17. Then we simplify. Minus 3 minus 17 is minus 20, and that's our answer. Now for question number 2, we're actually going to isolate or single out the term called 4p. Now, in doing so, what we're going to have to do is we're going to have to move the plus 12 to the other side. And notice how I'm always moving it to the right side of the 15. And then what you're going to do is you just copy down everything exactly the way it was before, except the plus 12 becomes minus 12 to the right of 15. And then we simplify 15 minus 12 because there's nothing more to move since 4p is where we need it. So now we end up with 4p is equal to 3. Now, the next case we have to do is we have to look at this as 4p's, which is 4 times p. Now that 4p that we have on the right side, the term there, we have to get rid of it by dividing both sides by 4. And we end up with p is equal to, well, we could write 3 over 4 as our answer, or we could write 0.75. Pause here and then continue. And now we'll move on to the next question. So we got negative 5n minus 17 minus 2. So what we need to do is we need to isolate the negative 5, and i.e. we're making sure it's staying on the left side of the equation. Now, notice I have negative 17 on the right. I don't want it there, so I have to move it to the other side. So now I have negative 5n is equal to negative 2. We just copy that down, and then we have plus 17. Negative 2 plus 17 is going to be 15, and negative 5n doesn't change on the right side. And now we have to get rid of that negative 5n. So we divide both sides by negative 5. So we end up with n is equal to negative 3. Now let's take a look at the next problem, question 4. The biggest issue here is that we have a fraction sitting in front. And to get rid of the fraction, what we want to do is we want to actually multiply every one of the numbers in this equation by the denominator, 3. So multiplying 2/3 times 3 will cancel out the bottom part of the fraction. So with math, we usually try to make stuff look like what we know before. So we take a look at 4, and what we're doing is we're going to turn it into something that looks like 3. So we're going to multiply the entire equation by 3. In doing so, we force our equation to look like question number 3. And so we'll do that right now. We multiply each thing by 3. Now, if we take 2/3 and multiply by 3, yes, you're right, we're going to get, I think it's going to be 2x. And then we minus, well, negative 1 times 3 is negative 3. which is equal to 15. Excellent. And now we're back to what we were doing before. We're isolating 2x and moving the negative 3 to the other side. In doing so, we get 2x is equal to 15, and minus 3 becomes plus 3 on the other side. And that creates 18, and 2x is 18. Now we have 2x. We need to divide both sides by 2, and we get x is equal to 9. Pause here. Now, from now on, questions 5 through 8 are going to involve multiple steps. We're going to always try to make sure that our variables are on the left side of the equation. For question number 5, you'll notice we have m variables on both sides. Okay, and now what we want to ensure is that our variable is pushed to the left side. So what we're going to do is we're going to isolate everything to the left. So we're going to move the 7m. And remember how we moved stuff to the end of the first equation on the right side? Now we're going to move anything from the right to the front of the left side. So now we're going to have negative 7m minus 2m plus 14 equals 23. Now that's because plus 23 is the same as 23. And now what we'll be doing is we're going to look for anything on the left side that doesn't have an m in it, and we're going to move it over to the right. And notice how we're always putting it to the end on the left side, on the right side. So now we got 23 minus 14. And then all that's left over on the left side is this, negative 7 minus 2m. Now that we have all our numbers and everything else organized, all we have to do is just collect like terms. So negative 7 minus 2m is negative 9m. And 23 minus 14 is 9. And now we need to get rid of the negative 9m. And we end up with m is equal to negative 1. And we're done. Now, number 6. We have some more difficulties. We're going to have to use our distribution on 3. So we got 3 times x, which will give us 3x. And we'll also have plus 12 because 3 times 4 is plus 12. And now we need to isolate x. So we're going to move the 12 to the other side of the equation. And we're isolating 3x, i.e. leaving it on the left side. So we end up with 3x is equal to negative 15 minus 12. And now, since 3x is by itself, we can leave it, but we have to collect the right side. So the right side ends up being negative, I think, 27. And now 3x, to get x by itself, we divide both sides by 3. So we end up with x is equal to negative 9. And now, pause here. Now we'll work on question number 7. Question number 7 is interesting in the sense that we have, for our denominators, like we talked about before in our fractions, we have 5, 2, and 4. And what we're looking for is the least common multiple between all of these. And if you think about it, the least common multiple, or the thing that basically divides all of these numbers, the 5, the 4, and the 2, is 20. So all of those numbers can divide the number 20. So we're going to use that to multiply everything first. Notice, every number that's sitting in front of a bracket or a variable must be multiplied by 20. So 2/5 times 20 gives us, I think it might be 8. And then we're left with x plus 3. And then we'll do the same again for 1/2. 1/2 times 20 is 10x. And then minus 3/4 times 20 is negative 15. So now we're back to a problem like question number 6. Now let's distribute the 8 into x plus 3. Don't go chasing waterfalls, children. So now we have 8x plus 3 is equal to 10x minus 5. And now we're using the techniques that we used in question number 5, where we isolated x by moving all the x's to the left side and all of the numbers to the right side. So let's go and move our x's all over to one side. To do this, we're going to take 10x and move all our x's over to the left side. So I'm actually going to take that x, that 10x, and I'm going to move it to the front of this equation here. So now we're going to get the following solution. You'll notice that the 8 becomes plus, the 8x becomes plus 8 because it's kind of like we have to recognize that plus sign, that unimagined plus sign. Now, let's move on to the next part. We need to move 24 over to the end of the right equation. And we get this solution. Now, for our almost finished final step, we must add like terms or collect like terms. And we end up with negative 2x equals negative 39. And to get rid of the negative 2, we divide both sides by negative 2. And we end up with x is equal to 19.5. For question number 8, it involves a combination of all of the steps that we have done. Now, you'll notice we have to do our waterfall technique, our distributive property, on some parts in order to get rid of our brackets. So we'll have to do that immediately on the first line. So let's do that. Now, when you do your expansion, your distribution, you get the following. You'll notice that the entire equation is just a mess. It's unruly and it's cumbersome. So if you want to make your life easy, focus on each individual side and make sure that you've collected all of the like terms. And let's do that using our steps from class. So on the left side, we're going to get the following. And we get this because there's no real rearrangements to do. So let's collect the like terms on the other side here. We'll put the t's first and then the constant second. So just remember, as you go through, you should kind of cross off these things here, so that lightly cross off these on your pen, on your sheet, so you know that you've arranged, that you've gotten all of the numbers in this list from here, but put them in order. Now we'll go and collect the terms appropriately and rewrite our fourth line. So we end up with this final equation. So now we're back to what we started off. Remember equation 1, we had to just move stuff to the left side and the right side. So let's do that now. I want all my t's on the left, so I'm actually going to highlight it and move it to the front of this equation, and we get the following line. Now, you'll notice all the t's are on the left side. And now we need to get rid of this minus 3 by moving it over to the left side. And we'll literally just move it over to the left side. And we get this 16t plus 3t equals negative 57 plus 3. And negative 57 plus 3 is negative 54. And 16 plus 3t is 19t. And now what we have to do is we need to get rid of our 19, so we divide both sides by 19. And we end up with t is equal to negative 54 over 19, or some ugly decimal. And I'm not going to do that decimal because it's just ridiculous. Now, your homework is question number 1 to 3, A, C, and E, 6, A, C, E, G, I, and K. These questions are going to be posted online. I'm going to release questions number 1 to 3 for you online for the weekend, or you can do those in class, and we'll try to finish all of this on Monday. Good luck, guys. And don't forget to do 6 ACEGIK.